Hello, 7th graders. This is Miss White, and today we're doing lesson 13, changing scales. To change scales, we need to use a scale factor. And let's review what a scale factor is. So a scale factor is going to be the number that we multiply to tell us whether or not there is an enlargement of the picture or a reduction of the picture. To do that, we would take the length in a scale drawing and divide it by the corresponding length in the original drawing, okay? So when we look down here, it says use the two drawings below to complete the chart. And the chart we're going to be filling out is over here. Now, from drawing 1 to drawing 2, we need to find the quotient of the corresponding horizontal differences. So when we think about the quotient, that means an answer to a division problem. And we know by looking over here that we have a formula set up for division, which is the length in scale drawing divided by the corresponding length of the original drawing. So here, drawing 1 is going to be our original, and drawing 2 is going to be our scale factor. So for our length, which is here, we're going to have 3 92/100 over 2 45/100. Okay? Go ahead and take your calculator out and solve our division problem. Okay, you should have got 1.6. Okay, now let's find the quotient of the corresponding vertical distances. So here's our vertical distances here. And still our drawing on the left is our original and the drawing on the right is our scale factor. So we're going to have 2.4 divided by 1.5. Go ahead with your calculator again, solve this division problem. Okay, and you would have gotten 1.6 again. Now we need to write that scale factor as a percent. So we have 1.6 equals, and how would we write as a percent? Percent means out of 100. And so when we have 1.6, that's going to give us 160%. Now, is this a reduction or an enlargement? Well, we see here by looking at our pictures, our photo is enlarged, okay? But another way to figure that out is that if it is over 100%, that also means it is enlarged as well. So I'm just going to put E for enlarged. Okay. All right. Now, it wants us to do the opposite. It wants us to go from drawing 2 to drawing 1. So I'm going to go ahead and erase this. Let's see. Okay. And again, I'm going to put here that this is going to be our original now and that this is our scale factor. So let's go ahead and use our quotient of the corresponding horizontal differences. So I'm going to have 2.45 divided by 3.92. Go ahead and take your calculator and calculate this. All right, so we would have got 0.625, and that's okay that I went over into the other box. Okay, now we need to find the quotient of the corresponding vertical distances. So I'm going to take 1.5 and divide it by 2.4. Go ahead with your calculator again and calculate this quotient. Okay, and again we would have got 0.625. So now that we know they're both the same, we know that there's a scale factor. But now we need to turn this scale factor from a decimal to percent. So one way we can do this is we can move our decimal to the right 2 times. So we go 1, 2. And so now we know that it's going to be 62.5%. And now, is it a reduction or an enlargement? Well, we know that is a reduction because we're going from this larger picture over here to the smaller one. But also we know that it is a reduction because the percentage is less than 100%. So I'm going to put an R for reduction. All right, let's look at example 2. A rectangular octagon is an 8-sided polygon with side lengths that are all equal. All 3 octagons are scale drawings of each other. Use the chart and the side lengths to compute each scale factor as a percent. How can we check our answers? To find the percent, we can use the formula quantity equals percent times whole. So we're going to start out from drawing 1 to drawing 2. Drawing 1 to drawing 2. Now, to figure out this percentage, we need to label which one is going to be our quantity and which one is going to be our whole. So actually, our whole is going to be our original, which is drawing 1, and then our quantity is going to be drawing 2. So now when we look at this, we can say, okay, our quantity has a value of 12. So 12 equals our percent, which we don't know, and we can use as the variable p, and whole, which is 10. Now, go ahead and let's try to get p to be by itself. So to get p by itself, I'm going to divide 10 from both sides. And so now I know that I have 10 divided by 10, which gives us 1p, and 12 divided by 10, that gives us 1.2. So now we know that our scale factor is 1.2. But now we also want to turn this into a percent. And one way to do that is we're going to move the decimal over to the right twice. And so that's going to give us 120%. To find the equation to illustrate the relationship, we want to know what's going to give us or get us to our quantity. So we know our value for our quantity of drawing 2 is 12. And we knew that 10 times 1.2 is going to give us 12. All right, let's do drawing 1 to drawing 3. So here we're going to have drawing 1 still be our whole, and then drawing 3 is going to be our quantity. So when we set it up in quantity equals percent times whole, I'm going to have 8 equals my percent, which is going to be represented by the variable p, times our whole, which is 10. Now to get p by itself, I'm going to divide both sides by 10. And now I have 10 divided by 10, which is going to give me 1p. And then 8 divided by 10 is going to give me 0.8. Now, let's figure this out as a percent. I know if I move the decimal over to the right twice, I'm going to get 80%. And the equation to illustrate this relationship is that I'm going to take 10 times 0.8, which is going to give me 8. All right, let's go from drawing 2 to drawing 1. So drawing 2 now is going to be my whole, and drawing 1 is going to be my quantity. I'm going to have my quantity of 10 equals my percent, which is being represented by the variable p, times my whole, which is going to be 12. So now to get p by itself, I'm going to divide by 12 on both sides. 12 divided by 12 is going to give me 1p. And then I know that 10 divided by 12 is going to get me 0.83 repeating. And if we want to write this as a percent, it's going to be 83.3 repeating percent. Okay, so now when we set this up as an equation to illustrate this relationship, we're going to have 12 times 8.3 or 83.3, sorry, repeating equals 10. Okay, now we're going to go from drawing 2 to drawing 3. And my drawing 2 is going to be my whole, and my drawing 3 is going to be my quantity. Now I'm going to have my quantity of 8 equals my percent of, which is represented by P, times my whole, which is 12. To get P by itself, I'm going to divide both sides by 12. 12 divided by 12 is going to leave me with 1P. And then 8 divided by 12 is going to give me 0.66, repeating. To write that as a percent, I can write it as 66.6 repeating percent. And then the way that I show this in an equation is going to be 12 times 0.66 repeating equals 8. Now, from drawing 3 to 1, I'm going to have my 3 be my whole and 1 be my quantity. So I'm going to have 10 equals my percent represented by P times my whole, which is 8. To get P by itself, I'm going to divide both sides by 8. 8 divided by 8 is going to leave me with 1P. So 1P equals 10 divided by 8, which is going to give us 1.5, or 1.25, sorry. And when we make that a decimal, it's going to be 125%. The equation to illustrate this relationship is going to be 8 times 1.25 equals 10. And finally, from drawing 3 to 2, I'm going to have my drawing 3 be my whole again, and drawing 2 be my quantity. So I'm going to have 12 equals my percent times my whole of 8. To get P by itself, I'm going to divide both sides by 8. 8 divided by 8 is going to leave me with 1P. And then 12 divided by 8 is going to leave me with 1.5. So as a percent, I'm going to have 150%. To write this as an equation to illustrate the relationship, I will have 8 times 1.5 equals 12. And that concludes today's video. I will see you guys in class.